All right, so welcome to another episode of Phoenix VR for Good. We will be focused on the state of the art during this presentation. It is incredibly generalized with what's happened concerning Metaverse technologies and the interest during the pandemic in immersive systems and telepresence. There is much more to be covered than we can do in about an hour, hour and a half's worth of time. So this will be pretty rapid fire. And what we'd like to do is state of the art kind of sets the tone for the rest of the year. So if there are things in here that you would like to see more presentations about, or guests, or more insight, please let us know, because we'll build other sessions or other workshops based on what you're going to be seeing like over the next hour and a half. So the main takeaways, things to know. Technology adoption, like what's going on with AR and VR. Interoperability, this is a word that thankfully has finally popped up within this technology stack, within this industry. I'll be describing what that means and how it affects us that either are using or building these systems. A little bit of artificial intelligence, and I've stacked artificial intelligence, maybe general artificial intelligence, with a little bit of virtual assistants or avatars. It's a little bit intentional, and it'll make sense once you see how these technologies start to affect one another. They aren't necessarily primarily related, but artificial intelligence and VR assistants may be of interest to some of you also. So I give some examples of how those things are, the interplay between those two things. And then emerging use cases. This is just things that seem kind of interesting that have popped up in the last like 6 to 12 months that maybe we wouldn't have seen or couldn't have seen when we started this group, almost a half decade ago. But first, something dystopian. So let's set the stage, right? The metaverse appears to its users as an urban environment developed along a single 100-meter wide road, the street. It runs the entire 65,000 kilometer circumference of a featureless, black, perfectly spherical planet. The virtual real estate is owned by Global Multimedia Protocol Group, a fictional part of the Real Association for Computing Machinery, and is available to be bought and buildings developed thereupon. Access to the metaverse through Bob Wright's global fiber optic network, which grew from a collection of small cable television franchises into a global telecommunications monopoly and superseded the traditional telephone system. This is a vision of the future that was given to us a few decades ago now in the book Snow Crash. And I just wanted to kind of give you an idea of this really kind of awful dystopian vision of what the metaverse was. I don't necessarily think, and this is my opinion, that it's the proper North Star for maybe what we want to build. That being said, we're doing it anyway. This is a screenshot of Creta, which was created by Unit 2 Games, which was recently acquired by Facebook, which happened to change its name to Meta, referencing very heavily in its internal documentation and guidance the metaverse that was written about in Snow Crash. So it's a weird life imitates art thing that's happening right now. And the state-of-the-art presentation that you're watching right now is going to talk about what influences perhaps that implementation is going to have on our reality and how we are mitigating some of those potential dystopian outcomes. So let's talk hype, right? Now that I brought you all down, let's go back up again. So this is the hype cycle from 2018. If you're not familiar with it, Gartner released this chart. They release this chart every 6 months, I think it is, to describe where the adoption of a particular technology may be. As you can see, this is from 2018, so this is now what, 5 years old or 4 years old. it can tell you where things are starting to appear, emerging technologies, emerging use cases. And in this case, you can see that augmented reality is in the trough of disillusionment. So let me explain to you kind of what you're looking at. So in the beginning, the innovation trigger, it's the tech, it's the chip, it's the use case, it's the new modality that makes this innovation possible, this technology possible. And so people get super pumped because they start to see what's possible through this new innovation, whether it's plastics or aerospace materials or artificial intelligence. They all at some point, according to Gartner, end up on this type of cycle. And so the innovation trigger occurs, and suddenly there's all this hype for the technology. And then what happens is that as we start to use it and as we start to implement it, we get to the peak of inflated expectations, which is, oh man, the thing that I thought was going to happen might actually be like after I pass away. Like it could be 50 years from now. Or it just, somebody overpromised, right? Whether it was the PR group that overinflated it, or the investors that wanted to turn a quick buck on the innovation itself, or even the engineers or the makers of the technology that just really kind of reached a little too far in what they were saying was possible in the immediate future. So after we reach that peak of inflated expectations, we end up in this trough of disillusionment. This trough of disillusionment is, okay, great. So we thought we had something new that was going to radically change the world. Doesn't look like it's going to do it immediately. I guess we're going to have to pick the next great thing. And in some cases, technologies end up, or these innovations end up in this trough of disillusionment, and they don't go anywhere. I'll give you one that was kind of interesting to me. There's been a lot of research recently, particularly over at Arizona State University, around being able to smell virtual environments and virtual objects, which I think is really interesting. But if we look back, like, not quite the same thing, but immersive systems like movie theaters that had smell-o-vision are over 50 years old. And so somewhere along the line, we decided smell wasn't that important to us. So it kind of stayed in that trough of disillusionment. Now, something interesting happens when you end up in that trough is that if you have a particular resiliency toward implementation, what you might end up with is iterations, long iterations, that get you out of that trough. And so this is where we start to see the slope of enlightenment, right? As far as VR was concerned, VR was going to be everything to anyone. You could do anything at any time. And we realized that it was much harder to implement a lot of these visions and dreams of the future, but that some of them actually were possible and are possible with the current state of the tech. So that slope of enlightenment starts to inform both the user and the implementer of the technology. And where we end up with is actually a place of like actual use and mass adoption called the Plateau of Productivity. And so what you're seeing here is a chart from 2018, just kind of mapping out some technologies, connected homes, virtual assistants, blockchain technology, things like that, that are generally out and being used in some way. But Gartner has tried to establish this this hype cycle to get us to understand where it might be in the adoption of that technology. So here's the 2021 version of the hype cycle, right? We've got NFTs right there at the peak of inflated expectations. Digital humans a little bit closer to the innovation trigger. They're pretty much being hyped. These are things that we're going to talk about a little bit. Quantum machine learning, right? Like that sounds cool. So does time travel. But like these are all things that might be possible, but we don't know yet to the extent of what can be accomplished in the immediate future, which is always of interest to us as, I think, early adopters. I think most of the people that are logged in or watching this kind of stuff are still fairly at the beginning of the adoption cycle. And so let me describe that for a second. So this is the diffusion of ideas. Diffusion of innovation. What you see here is how market share for a particular innovation or technology grows over time. And if you compare it kind of to what's happening with this hype cycle, once we get out of the trough of disillusionment, there's an opportunity there for early innovators to make really amazing changes in the way that we interact with one another. I believe that where we still are is in this innovators, potentially the beginning of the early adopters part of this innovation cycle. So VR headsets, I'll talk about it a little bit. In 2016, there were 5 million VR AR HMDs had been sold in 2016. By 2020, we're looking at 68 million. Okay, and that's in 4 years, right? We're talking about a 10x multiplier, over 10x multiplier in units sold within 5 years. If we go back to this diffusion of innovation, what we might be seeing here is, okay, we've got these early adopters starting to use the technology, starting to build in this technology, but we're not at early majority yet. Early majority, once you get there, you're looking at over half of the population or half of the potential market share adopting this stuff. I don't think we're close yet. So that gigantic wave that's coming of AR, VR, XR, Metaverse, whatever you might call it, we're still at the beginning. Although it may seem like, all right, these presentations have been given since 2016, 2017, it's still early. So has anything occurred in the previous 5 years to promote telepresence and telework, right? Like that's a no-brainer. Global pandemic, which began in spring of 2020, has promoted telework and telepresence technologies. However, screen and camera fatigue has produced interest in immersive and more holistic approaches to work and play, right? So like, what if you could actually like be in the thing? What if you could actually be with a friend? And so the Oculus Quest and its successor, the Quest 2, have shown that there is a market for VR at a sub $500 price point. Meta, formerly Facebook, has used the terms interoperability and open to describe its future vision of this metaverse. What type of interoperability they want is yet to be seen. There was a period of time when you could log into an Oculus Quest without using a Facebook account, and then that went away. And then they're saying they're kind of undoing that. But the real question is, once you're in their metaverse or in their system, what kind of interoperability might they have with external systems? What kind of sharing opportunities will they have with non-Facebook Metaverse Meta systems? Those are things to think about. Here's another interesting innovation that has occurred as we're talking about hardware. This is the Tesla suit. The Tesla suit is a full body suit that is worn very much like a wetsuit, and it has programmable interfaces so that if you're using an augmented reality or virtual reality head-mounted display, it allows you to actually feel those the interactions that you're having in those virtual environments. I was able to wear one in January of 2020, and after taking half an hour to find the right size to wear, which is kind of hilarious in itself, they actually they had everything to 100% force feedback. So I was able to feel the rain like fall on my shoulders and down my arms. It was absolutely surreal, but we're still establishing best practices for a lot of this stuff. So I got like zapped because what it's doing is that the interior of the suit is actually got little electrical nodes that are zapping you just a little bit at a time. And since those best practices weren't established, the Tesla suit was only a few months old, they had it cranked up to 100%. My tolerance is quite low. So we had to do some calibration, which itself took another 30 minutes. You're talking, like I said before, we're at the early stages of this stuff. 60 minutes just for me to be ready to be in an experience. I don't know that that's going to work for everybody. You're probably going to want things that are more like strap it on your wrist so that we know that you've got full arms in VR, right? Because most of us only still have hands in VR, right? We don't even have feet yet. So what this is Vive recently released the VR wrist tracker last year for its Vive Focus 3 headset. And what the Vive Focus 3 headset does, it does inside out tracking. So there are cameras all throughout the headset that are meant to orient itself and the user to the environment that someone is in. Okay, so what I mean by that is I put the headset on, They're working on algorithms, right? Anybody that's doing inside-out tracking are working on algorithms to be able to recognize objects and do segmentation so that this tracker technology that we've had in the past, which is like you make a virtual fence and you hope you don't hit anything. Well, the technologies are advancing fast enough that the ability to create environments based on just what the headset is aware of around you is starting to show up. In the case of this tracker, this wrist tracker, it's meant to be able to provide the positional information, the orientation of your hand and your elbow to the headset. Because if you think about the cameras and you move your arm beyond where the camera can see, you've now lost, it's now lost the ability to track that. But if you've got these devices, let's say strapped onto your shoes or strapped onto your arm or wherever it might be, your ability to represent all of yourself in an immersive environment becomes much easier. So I think what we're going to start to see is more things like this start to show up in addition to the optical algorithms that do hand tracking or feet tracking with the cameras. These are just, I just wanted to show you some examples of some hardware that has started to show up that creates deeper immersion. So technology adoption. 5 million AR/VR headsets were sold in 2016, 68 million sold in 2020. I couldn't find up-to-date information yet for last year. I suspect that is quite high given that the Quest 2 price point was really appealing for a lot of people Christmas of 2020 and Christmas of 2021. The value of AR/VR headsets for work and play is becoming better understood as users purchase and use the technology and content creators become more familiar with the medium. That's pretty straightforward stuff, right? We don't know what to do with it unless we start to play with it. And it turns out that we can do a lot of things with it. And what those things are becoming clearer to the users as well as the creators, because the creators themselves, right? Most folks that got into VR, right? That this new wave of VR adoption, most folks got into VR after like the original Oculus headset and the first Vive headset, which was right around 2015, 2016. They didn't know what to do with it. And so where we're getting to now is this level of maturity. If you're thinking about that hype cycle, we're getting it to this level of maturity where there's quite a bit of enlightenment happening. Oh, you can do this, but you can't do those things. And those best practices are starting to appear, not only for the creators, but also for the users. One thing I put a note to myself here. It used to be if you had asked someone in 2018 whether they wanted to use a VR headset, most responses were, I'm probably going to get sick. That is starting to not become the case. And that was interesting to see happen in the last few years. It was just like, it was dramatic. Suddenly people knew what VR was, or at least had tried it and realized, I'm not gonna get sick every time here if it's done right. So interoperability. This is one of the things that I'm hoping you all will take away from this. So interoperability, what is interoperability? Here are a couple of definitions, both that I think are important. The ability of computer systems or software to exchange and make use of information. That's pretty general information. The ability of military equipment or groups to operate in conjunction with each other. I think when we take both of those things and we combine them, so the ability for computer systems and software to exchange and make use of information and operate in conjunction with one another is really what we're talking about. What that means is that traditionally, systems have been built very much siloed. So if you're playing a game on the Xbox even, there was a time when you wouldn't be able to play the same game with people on other consoles. That's changed. Now what we're talking about is the ability to move assets or to exchange information across systems that were not built necessarily to even know that each other existed. And by that I mean, could you buy an asset or a model or a thing on one system or create it in one system that might be three-dimensional and then have it instantiate in another system somewhere else? And that becomes important because as we start to think about these headsets being ubiquitous in our lives, we will all be on different systems. Interoperability is incredibly important so that we can actually share information across these systems, whether it's a recording of something, it's a pivotal moment, it's somebody's wedding or somebody's funeral even. Like that may be a type of asset, or it might be a villa in Tuscany, right? That you went to and had a beautiful dinner with your wife at. And you want to remember it, and you want her to have a copy of it too. And she wants you to have a copy of the olive grove, like, you know, off in the distance. But she's got an Android headset, you've got a Apple headset, somebody's got a Facebook headset. Interoperability is incredibly important if we're going to use these systems to be able to share it with one another. So as we talk about interoperability, this is just a really quick animated GIF from Play Canvas, which is a web-based viewer and interactive system. So there is a format that's starting to appear and really be adopted generally across a lot of different industries, which is the Gltf format. That's not to say that it's the best, it simply is one that is fairly easy to work with now. A lot of different engines and a lot of different systems are adopting Gltf as kind of a baseline for sharing three-dimensional assets. So all I'm showing here are these different assets in Gltf format in a web browser in a three-dimensional system. I'll give you kind of an interesting analogy to this, that by the late 90s, early 2000s, it was common at that time to build your own three-dimensional engine. So if you were going to make a game, because that's basically what engines were being used for, 3D engines were being used for then, unless it was like architecture or facilities planning. So if you were making a game, everybody was making their own engines. Within about 10 years, it had become pretty common to license engine technology. And so 10 years after that, it's become pretty common to license 3D assets. And these assets, having them in a common format that's interoperable across a lot of different engines or systems, makes it very easy to essentially build once and use anywhere. That's going to be very useful because the same assets that, let's say, you put in an artificial augmented reality garden in your backyard may be the same assets that you want to share in a virtual park, in a virtual environment in VR with friends. I will say that in addition to Gltf, Apple has pushed really hard for USDZ, which is derived from a Pixar format. USDZ, we haven't seen a ton of adoption outside of Apple projects for USDZ, but I suspect when, not if, when Apple releases their kind of first eyewear, that USDZ will become much more important than it currently is. So I wanted to describe those things. So as we talk about Gltf and these portable formats or interoperability, we're in a game, we're in a virtual environment, we're in an AR experience, or we're at work. What's really interesting with Gltf is that as the term digital twin got really popular in the last like 3 years, instead of OBJ, which was kind of like the de facto format for a while, Gltf can hold different kinds of information. It's a little more robust than OBJ. But organizations were starting to say, oh, I want to make a digital twin of my factory, or I want to make a digital twin of my building, and I want to be able to view it on a tablet or on a headset. How can we get it on there? And so that's where Gltf started to really show up in this digital twin adoption. And so there's this interesting dovetailing of digital twin technology and AR/VR use cases, right? Not only now do you have a digital asset that you can use to describe and visualize information, but you now have one that could potentially use to do training or simulations against. And so we're seeing use cases where whether it's training, situational awareness, asset tracking, or forecasting. These common formats are giving us the ability, these interoperable formats are giving us the ability to do all those things across a ton of different systems with the same assets. And so I wouldn't, I couldn't get out of interoperability without talking about NFTs. So NFTs have been explained in popular media primarily as a way for asset speculators to make money. However, the underlying infrastructure for infrastructure for the assets hints at decentralized and interoperable assets that will someday inhabit our own virtual worlds. Some of the examples that I thought to put here were NFT of an entire human medical record at a moment in time, NFT of a deceased person's last words, an NFT of previously unshareable objects, things that might be stored in a vault, things that might be too delicate to be shared, might be things that exist in a decentralized way. It doesn't have to be blockchain, but in some kind of decentralized format that we can then share across a lot of different systems. That's an interesting use case for NFTs. I thought I would attack that one in that way. Of course, there's always the speculation component, but I think there's much more. There's a much richer opportunity than just money making. That's a great one, but also in provenance and showing things across time. And so that's why I wanted to bring up NFTs here as we talk about interoperability. So ubiquity of AR, VR capable devices, whether it's a phone or a headset or eyewear, is forcing asset standardization, make once, use anywhere. If we're to rely on immersive systems to help us operate the world, we will need these systems to be interoperable. However, I want to say that there's more, right? Interoperable is great, but they also need to be resilient. They need to be extensible and modular, right? If I want to mix and match my own thoughts on how the world should look, and I have the ability to do that, I should not be restricted by the system to allow me to do that. I shouldn't have to only be able to log in one way, and it shouldn't, at least I think it shouldn't exist in only one location on only one organization's servers. So interoperability is great. Definitely, there's a learning moment, I think, for the entire industry as we talk about it, but there's also resiliency, extensibility, and modularity. And I think as we get into this kind of this enlightenment moment, I hope that we'll start to see these other terms show up as well. So since we were talking about AI, let's open the pod doors. This is the Magic Leap 2. This is a teaser because it's not available to everybody yet. There are approximately 18 distinct sensors on the Magic Leap 2. And I wanted to start this discussion on artificial intelligence by first kind of positing a question, which is, how many sensors do you need to predict the future, right? Like that's kind of an interesting one as we talk about sensor fusion and the ubiquity of these kinds of headsets and eyewear, right? Like there are 18 sensors just on this one, and we're at the beginning of this adoption, right? Every single one of us that's watching or logged in to this presentation, there will be a future when that is attainable for all of us. And what does that do when we start to think about how to measure or how to predict or how to interact with the environments that we're in the future? Okay, so I'll give you an example of something. This is a simulation of a robot grasping items. It's built in a three-dimensional simulation platform. The environment itself is called a gym, right? So like you can build different kinds of things in these gyms. And these gyms are developed using OpenAI software. OpenAI is a company that was founded a few years ago. One of the co-founders was Elon Musk, and they make arguably one of the best general AI systems that are available to the public. So this is a simulation, right? This is a simulation that exists in this AI technology platform. There's talk within multiple industries to use edge computing to create simulations that can be visualized on top of real world environments. So this is not happening in the real world, but think about this. What if you had the real world in front of you, an AR, VR headset that is measuring that world with those 18 sensors, and then is overlaying that simulation in that real world environment? How much more throughput is possible? How many more things can I stack? What is the safe distance when I install the robot next to these other objects and human beings? So it's a little bit of a jump there, but artificial intelligence being used to augment the way that we think about the world. Right now, it's up to us, right, to create these mental models of how we might interact with the environment around us. But we're not that far off, and there are some applications already happening where stress testing or heat visualization, but like heat in the future. So like, let's say I'm looking at a pipe. I know that that pipe could potentially get to a certain temperature, but it will only get to the temperature if I interact with this knob over here. I interact with the knob, the AR software sees that I'm interacting with the knob and then says, hey, be very careful because this pipe is about to get really, really hot, but it hasn't gotten hot yet, right? Like the ability for artificial intelligence to help us simulate what will happen in the very, very near future, talking like seconds from now. Hey, don't cross the road. That car will likely make a left turn. It's 90% probable that that car will make the left turn as you're crossing the street. Things like that. Okay, and there are lots of interesting applications for that, both on a personal level and at an industry level, right? Providing guidance for you as you're walking around, and also on how to run your factory, that kind of thing. And this is where I make the jump. I talked about it right at the beginning, where I kind of put together AI and three-dimensional avatars. They aren't distinctly related, but there's quite a bit of overlap. There's quite a bit of overlap. And so we're going to talk about Emma. Emma's not real. She was commissioned by producer M, who is out of Japan, and modeled by Modeling Cafe Inc. Her name is inspired by the Japanese word ima, which means now. She's been active on Instagram and reps a few brands, has been repping a few brands since July 2018. Almost indistinguishable from reality. If I'm wearing a sufficiently advanced headset, pair of glasses, VR, HMD, I might have a hard time distinguishing. We might have a hard time distinguishing whether this three-dimensional asset, this immersive model is real. I think that I wanted to get into potential pitfalls here, but we're just going to stay at the high level, which is that we're getting very close to a moment in which virtual human beings are indistinguishable from real ones. Okay, it's still on the horizon. Interactivity sucks pretty bad right now. They're kind of dumb in their responses to us for right now. But if you think about the simulation characteristics that we were talking about before, and the sensor fusion technology with it, you can rapidly see how if all of us are wearing headsets and all of us are crunching these algorithms and these numbers, and we're sharing them collaboratively because these systems are interoperable, that things like virtual humans are going to get really smart really fast. This is an interesting one. I saw it in at CES this January. So CES is just the Consumer Electronics Show. You know, we're still in the pandemic. So it had an audience of probably like a quarter of the people that normally show up. Was kind of nice to be able to walk around an empty, not empty, but mostly empty trade show, considering the fact that CES has traditionally been one of the most popular trade shows in the past. But it was wild going from attending CES in 2020 to suddenly attending in January 2022 and being greeted by these synthetic human beings. This is a combination of, this is 3D modeling, voice synthesis, and if we think about sensor fusion, some of those 18 sensors that we're talking about, right, that will probably have some predictive stuff with them. If you combined this kind of stuff with sensor fusion setup, you could potentially have an assistant that can predict what you might ask or predict how you're feeling. So let me show you what this looks like.
By video synthesis technology of deep brain AI.
Hello there, I am not a real person, but an artificial human created by deep brain AI.
Hello there, I am not a real person, but artificial human created by video synthesis technology of deep brain AI.
Hello there, I am not a real person, but artificial human created by video synthesis technology of deep brain.
Hello there, I am not a real person, but artificial human.
So you get what I'm saying. It gets really weird, really fast, and really interesting and really powerful, really fast. That was state of the art, January 2022, right? So like where are we going to be in 12 to 24 months? All right, so artificial intelligence, 5G and edge computing provides unparalleled opportunities for real-time simulations to appear overlaid on top of the real world. This is of extreme value to anyone doing predictive analysis, forecasting, data visualization, or mass manipulation. Greater API offerings are making AI integration into XR systems easier. AI was, of course, on that hype cycle. We really needed an easy way to integrate it rather than cooking our own. What's occurred in the last 5 years is that AI APIs, programmable interfaces, have become much easier to integrate with these 3D systems. And so those two things, again, they are dovetailing as well. Virtual 3D humans are starting to appear. They're still very simple, and our interactions with them are currently limited by our ability to view digital artifacts in the real world. You'd have to, for most people, the only way you're going to interact with a three-dimensional human outside of having a VR headset is probably on a phone or a handheld device. That's not the easiest way. There's a lot of friction there in being able to interact with a virtual human. When the display is on your face, that could radically change. And this is always like my favorite part because like we get to talk about the future. So the following are emerging use cases which may have a profound impact on how we view education, play, and reality itself. So this is one that I saw at Augmented World Expo back in November. This was a volumetric capture. To give you an idea of how far along these kinds of technologies have come, it used to be that people could say a minute might cost you $100,000 for volumetric capture. We're now at a point where a minute is probably going to cost you sub 5,000, and that has occurred in less than a decade. It's happened pretty rapidly. We're still not at a place where it's maybe cheap enough to do for everything, but I wouldn't be surprised if we have a FIFA or a Super Bowl that's done volumetrically soon. So let me just show you an example of what I mean by these volumetric captures.
And then we have all the integration tools like plugins for Unity, Unreal, WebXR, and then so the data in our own compressed format and optimized can be played in AR, VR, on every platform, like this on mobile, VR headsets, everything.
So you can probably imagine, right? If we're talking about a future that is now, that has 18 sensors on a glasses-based device, being able to project this into our eyes, that boxing match or the MMA match could happen in your living room, right? You're not looking at it as a miniature. You're actually looking at it in the environment that you're in. That is in the very near future. What kind of adoption that may have in terms of entertainment, I couldn't predict that, but these are emerging use cases. So here's an interesting one. So at CES, you know, I've been a few years, and LiDAR is part of this technology stack that allows you to be able to create these volumetric recordings or these holograms as well. It's not quite holography, but anyway, the ability to capture three-dimensional information has become incredibly important to all kinds of industries, from driverless vehicles to asset tracking companies to modeling and simulation companies, and now entertainment, as you saw in the one before. This is simply what I'm showing you here is the fact that there was like just a field of LiDAR companies at CES this year. They were like everywhere, and it was how fast or how cheap. And in most cases, it was about the efficiency of the technology and where it belonged in a workflow to do other things. So as I approached each one, they would ask, so what industry are you in? And they would have, of course, a slick or a handout if you were in oil and gas, if you were in security, if you were in artificial intelligence or automated vehicles. So there's a very, very large opportunity now for volumetric sensors, sensor developers, which is going to force the price of that to just like go down, 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 down. And if we're talking about the future, this one I will guess, 2-3 years from now, we're all out to dinner enjoying a VR for Good meetup. Some of us have these glasses on, and we can record the entire thing, right? And share it almost as a memory to one another after it's happened. And even those that don't have AR and VR, we saw with the Gltf interoperability slide that they could potentially watch it on the web, right? Like actually like move around in it and see it almost as if it was a three-dimensional, well, it would be a three-dimensional recreation of the entire event. We're very close to that now. So low latency, very low latency. You know, there's still some noise algorithms that need to be applied to this, but all they're showing here is that they've got a chip or they've got sensors that allow us to do this. So now that we talked about being able to record a thing, since this is emerging new use cases, this might be one of my favorite things. This is tele-reality, okay? This is reality being reconstructed by a sensor in real time. So this isn't a recording. This is literally the programmer moving around in three-dimensional space and then traversing the actual environment to record themselves in real time. There's no recording here. Like this is a live stream of a three-dimensional space. Does that make sense to everybody? If you think about these sensor fusions, like thanks. If you think about sensor fusion, right? This is one sensor. We're talking about 18 on the Magic Leap 2. And if we've all got these different headsets and these glasses or the whatever it is, and we've all agreed to record this space, it's only going to become richer. It's only going to become fuller and more, I don't know, I hate to use this word, but it's an interesting one, true. It might maybe become more true, which is going to cause a lot of disruption, I think, potentially, when it comes to law enforcement, when it comes to land disputes, when it comes to memory itself, like reliving memory itself. I just wanted to show that one because I thought it was really interesting. The fact that like, that's fairly new. That's it was possible before, but the fact that you could do it on a super, super, super low budget now in real time is just extraordinary because it portends to a future of complete capture or very near complete capture. And so that leads me a little bit to the work that we've been doing over at Baltu. We try not to talk too much about what we're up to, simply because like this is supposed to be a community thing, but I thought that this one fit in really perfectly. Like I said before, we're building a platform to train anyone to do anything. And that means a lot of really cool implementations of technology, some that may not have been traditionally thought of as educational. And so if we're talking about telereality or telepresence, let's talk about my coworkers. So my coworker's explaining a thing to me, and I'm like understanding the thing, and I'm glad that she's explaining it to me. But the cool part is that she no longer has to be there to explain it to me. Like, right? These are these emerging use cases. These are the new novel ways of using sensor fusion platforms to create actual usable tools. And that is why we have this meetup, right? This VR for good. And so as far as emerging technologies are concerned, things that you should be thinking about if you're thinking about the future, the near future, telereality, telespace. What are the effects going to be? Because they're going to be pretty robust on education, remote play, and remote entertainment. And there were a lot of paths that I could have taken during this presentation, but I wanted to make sure that I was fair to a wide breadth of things. And what we'll do throughout the year is we will pick individual ones here. Sounded like there was some interest in AI, and then haptics. Dawn sounds like you had some interest in haptics. And so that's it. Again, I was Fox Bonilla. I am Fox Bonilla, CTO of Baltu Technologies. You can reach me on most platforms at Harbinger Alpha. Any questions or any thoughts? Thanks, Aaron. Yep, go ahead.
I was just going to say, I really think the volume, anything that I think you can predict the volumetric video is going to be a massive thing. I shared I don't know if you saw it, but I shared on the web VR. Sorry, this is Austin, by the way. I'm a little frazzled. I was late. I shared a link in our chat. The Discord chat, yeah, of a volumetric video fashion show.
Oh, super cool.
So, like, if that advanced technology is already kind of reaching fashion, which isn't something I really perceive to be tech savvy, I think that's kind of noteworthy.
Yeah, that's really good insight. That's really good insight.
I'm sorry I missed the beginning of your, I was doing interviews late today, so
yeah, no problem, no problem. And we're just
I'll catch it on YouTube.
We're recording, so just so you know. Yeah, I think that's really insightful, Austin, which is that like this is like the opportunity to dramatically affect many different verticals and many different industries is pretty clear when it comes to three-dimensional information, because that is, like, as humans, that is the way we see the world, right? The world for most of us is not flat. I know some folks have depth perception issues, but even then, like, we traverse a three-dimensional world. So three-dimensional information makes a whole lot more sense than potentially watching a video. And that was of extreme interest to us at Baltu. And that's why we, that whole end of the thing, I think we're going to see a lot of solutions in that space. So Austin, do you remember the name of remember the name of the fashion show?
I think I have the link here.
Okay.
Oh, hold on. I got a D. I gotta eliminate the Discord tracking thing.
Okay.
Let's see, it was Maisie Willen hologram powered by Yahoo was what,
Okay.
but I'll paste it into the chat here.
And then a friend of mine had told me, actually, my friend, my freaking wife, had told me about this setup that was in Los Angeles.
Yeah.
I'm forgetting the name. The group was Subtractive, and they were using, is it called Portal? It's a 4K life-sized hologram display. Here.
4K life size. Wow.
Uh-huh. And so I saw a photograph of two astronauts in a separate room having a conversation, or sorry, they were having a conversation or something. And then this portal box thing was somewhere completely different and allowed you to interact with them.
Oh, that's sweet.
Yeah, and your brain is convinced that what you're looking at is like actually in front of you.
I've seen the little baby one.
Got it. Yeah.
Little holographic display, but that was very expensive and it was very small. I can't imagine how this larger one.
Yeah. I wonder what the folks at Yahoo were using. It'd be interesting to see what they were using.
Yeah, I don't know. I did share the link there. It's in the chat if you want.
Cool. Thank you. Any other comments, questions, concerns?
I do have it's two of the Intel RealSense cameras, which are stereo volume. They generate a volumetric video, and I was playing with them. I was trying to get them like streaming over the web, and I'm pretty sure that's possible. I forget what hang up I had, but I had some weird problem.
What kind of bit rate or what kind of bandwidth do you need? Like, what's the bit rate for the stream, and then like what kind of bandwidth would be useful?
I think I don't have the exact answers to that, but just like normal commodity, you know, like DVD level, like maybe 6 to 12 megabits a second type rates.
Wow, that's awesome.
Are sufficient. I don't know about the low latency. I don't know about the latencies on. Well, I guess
and does having two stack, like, does that give you more fidelity, or do you have to like match?
No, I don't know if you can join them in any way. So I have two just because they're two slightly different models.
Okay.
One does slam.
Okay.
Like it just spits out of because it has which is like the localization, like the robotics localization algorithm.
Mm-hmm.
So the camera spits out its position. So one of the things you can read off of the camera is just, you can see the video, but you could also see, the position of the camera in XYZ space and in just like a local coordinate system. And then the other one was designed for stereo volumetric type use cases. And I've fiddled with those both a little bit. They're kind of interesting. Oh, there you go. Good. Thank you.
And just to provide more context for people watching this afterward, so Austin mentioned SLAM. What SLAM stands for is simultaneous localization and mapping. It's just the ability to essentially provide geo-relative information from a sensor. So three-dimensional information that potentially a robot could use, a vehicle could use, any kind of any kind of system that needs to measure 3 dimensions.
Yeah, and so not necessarily the position on the globe, but the position within it. So like when you turn the camera on, it assumes that you're at 0, 0, 0. And if you move it around, like I actually picked it up, walked it out of a room, down a hall, came in a different door and sat back down and put it in the exact same spot to see, just as a test, how far, if you try and put it in the exact same spot, it should come right back to 0, 0, 0. It was off by like a few centimeters or something. But that was all derived entirely off of just RGB cameras.
And was that what kind of computation, like what kind of PC or what kind of system?
No, it's a standalone device that it has some sort of on-built tensor processor or some sort of onboard AI processing capability. Maybe it's an FPGA. I don't remember offhand. I might be able to find real quick the. Intel has a suite of RealSense cameras that provide that.
Yeah, this is all super interesting because again, this goes back to that sensor fusion thing where there's all this innovation occurring with these three-dimensional sensors, but there's also this other innovation that's occurring within display technology. And then there's all this other innovation occurring with three-dimensional representation of humans, and then the use of artificial intelligence. And we can see these things starting to kind of stack on top of one another to create things that were like, it's not just like they weren't possible a year ago. Like there, in some cases, we could not even have imagined that we could do it a couple of years ago. Right, and so this is a standalone device that previously probably would have required a multi-gigahertz machine to do the processing, and now it's like the real sense that Austin just shared is like just this camera that gives you that much information that you could freaking drive a robot probably through his house.
Yeah, you could just attach that to a Raspberry Pi or some other low-powered compute and read directly from that device the position information without having to do that computation yourself.
That's awesome. Any other thoughts? Any other insights? I know we blew through that pretty freaking quickly. And like I said, it's very generalized for anybody watching right now. This is like very generalized. We'll try to do a deep dive on any combination of those that you all are interested in.
I do like the volumetric helper, like at the end that you had there, the person who stands in your space and gives you advice or tells you, tells you about something. That's a really great use case. And the assumption that is like, we'll all have just glasses of some sort, right? That I think that's fairly obvious.
Yeah, that's where we're going. At least that's where I hope we're going.
Yeah. No, that's great. I'm sorry I missed the beginning.
No problem. No problem. All right. If there are no other questions or comments, I think that might be it for this particular meetup. The next one
I've got a question.
Yeah, Don.
Or a
go ahead.
comment. So with the volumetric video playing for, like, say, instructions on how to do something, so with that TV and that GIF that you were talking about, like if your angle goes more than like 5 degrees from where you started, it gets really like pixelated or like blocky, right? So what's your solution for that, or like the kind of like progress in addressing that sort of thing, or do you plan on, like, at least for now, like obviously it works just looking straight at it and stay still and it looks perfect, but in the future obviously you might want to spatialize it a bit more in terms of how you're moving around where the instructions are taking place. So how would you like address that?
Yeah, so there's I'll say this first, there's a little bit of IP there as far as what we're doing. But the previous slides kind of give you some hints of how it's going to be done, because a lot of people are doing similar type stuff if they're interested in volumetric recording. So Austin saying that, hey, you can pick up an Intel RealSense sensor. And then my immediate next question was, well, will it stack if you've got more than one? There are some use cases where you can only have one device or one sensor. In some cases, like the Magic Leap, you've got 18 different discrete sensors. Not all will be for volumetric information. But if you start to think about maybe the use of artificial intelligence to make up some gaps there, we get to really novel integrations of those technologies. And so I'm sorry I can't answer it like directly, but I think I just gave you...
I mean, it's more of like this is a problem that's like at the forefront of this thing. It's nowhere near being solved yet, is pretty much what it is.
Yeah, and there are methods to kind of making up for missing information. And so what we're working on right now is, this is one of several modalities that we see possible with these immersive technologies. I think we're going to have to do with good enough for a little while with some of them, because the great affordances that you get from being able to use off-the-shelf technology to do stuff that was previously impossible, the ROI is just so high, right? Like, so rather than kind of going down rabbit hole of setting up an entire rig or whatever to capture it in a way that's maybe a lot more accurate. Good enough will work, I think, probably for these first iterations of these headsets, like the ML2 and the HoloLens. It's a little bit, I guess my best analogy might be something like, yeah, it's black and white TV, but it'll have to do for a little bit.
Yeah, makes sense. What kind of like tagging along that last bit, what do you think of something like the new Vario high-end headset that kind of does VR and AR and MR like all in one? Do you think that's going to be more prevalent in the future, or do people here think that that's going to be more prevalent in the future, or like is that pretty much still like for a while yet it's going to be way too expensive to be in like a commercial space?
It seems that, I don't know if you've been reading up on what Apple may be up to. And there are other companies doing this as well, but Apple's kind of like the freaking gorilla right now, the hidden in the jungle. It's pass-through seems to be of high interest to them, at least. And it does look like Vive is doing, or HTC is doing something similar. And then also Meta, Facebook, is doing similar with the Quest. They've showed algorithms that can actually do pretty good inverse kinematics on the hands and even foot placement. And so I think what we're going to see, I mean, there was always this discussion early on when VR first started to show up in this new way. Which is it going to be? Which is going to win? In reality, they're all going to win because they rely on one another. So people are going to want portable systems, which means now that it's got cameras on the outside. The cameras on the outside allow you to do pass-through potentially if you've got enough resolution to not make the person sick. So now you've got AR within a VR system. I think convergence is the name of the game. Something similar happened with consoles around 2010. There was this talk. Sony had this talk, and they had this idea with the PS2 that there was this one device that was going to do all the things: watch movies, order food, chat with your friends, and play video games. And that seems so futuristic when we're still talking about the PS1 and the PS2. By the time the PS3 and the PS4 show up, specifically the PS4 is kind of the apex of that moment in the Xbox at that time, like the 360. Convergence is a no-brainer. That it's like, oh yeah, we went 20 years without being able to get on the internet on a console. How does that make sense? I think we're going to see a similar type of moment with AR VR. So whether we call it AR, VR, XR, Metaverse, whatever the heck it is, I don't feel like I don't feel like I have any concern as to what we call it. I really hope that it's all the things.
Yeah, me too.
And sorry, I totally answered that one. Anybody else got thoughts on convergence, AR, VR? Okay. All right.
I don't know if you can hear me, Fox.
Yeah.
I'm driving with the kids home right now, so it
Go-
might be on my
go.
like car speaker.
Yeah, please be careful, Peter.
Of course. The only thing I can see that could be an issue with pass-through is that you have to have very high fidelity cameras that also have low latency. I remember experimenting with some of the stuff that they had on the Vive Focus. And I know those cameras that they had on the front of the Focus were really low quality. But when you're in any sort of when those displays are placed right in front of your eyes, even a 4K image looks incredibly pixelated.
Mm-hmm.
And so I think pass through, they would have to pull some serious leaps and bounds in order to get passed through to be an experience, I think, of what we expect it to be. I think there'd be use cases where people would definitely it would outweigh, there would be value that would be added in a lot of different areas, but I don't know if it's exactly what we expect it to be.
Mm-hmm.
I don't know what's your thoughts on that?
Well, it's kind of interesting. You just got an iPhone 13, right?
Yeah.
Okay, so like I think you can put. Can you push 8K? Can you push 8K out of an iPhone 13? I don't know if you can. I think you can do 120 frames per second at 4K.
I know I can do. I can't remember what it is. I think it's 120. I don't know if it's at 4K or if it's at 1080, but
yeah, I think it's 4K.
It's getting better.
Yeah, I think it's at 4K actually.
Okay.
So if you think about sensor iteration, right, and that sensor fusion platform, I mean, Apple's a perfect example. They've got LiDAR, a macro lens. I mean, how many? 1, 2, 3, 4, just 4 on a modern, and this one's like a year and a half old. As we see these iterations occur, and you can there's a similar kind of setup on the Magic Leap 2 devices. I don't think we're that far from saying that a device could capture both depth-based and RGB data at a resolution, let's say, of a few meters at 8K. That's a mouthful there, but like I think we're probably like less than 12 months away from that. So if we're talking about the future, which is my favorite topic, if we're talking about the future, we're probably only like 24 months away, let's say, from that sensor fusion platform that could do pass through. I think if we're going on the idea that 8K is the demarcation line for reality.
Yeah, I think I can't remember what the pixel density is for like the human eye is where it starts to break down. I know, like, with audio, it's basically at it's the 44.1 sample rate, 44.1 kilohertz sample rate is kind of where it goes imperceptible, where you can't discern between what's real and what's not real if it's recorded appropriately. And so I think are we going to start hitting that mark as well when it comes to visual, and I imagine that there's going to be this convergence as well with AI, where it would be able to upsample, 4K to 8K or whatever, it's 12K images in the future, whatever it might be. But
right.
I think there's a convergence that will help there too.
Yeah, and that's really good insight as well, that if you need more resolution and it's okay with it being synthetic, in many cases, for most people, I think it will be, where it's mission critical to have actual reality. And this is so weird, right? Like that having a synthetic reality is enough for us to be happy with. I think you're right that the gap will be made up probably with artificial intelligence or some really savvy algorithms.
Yeah, they do that already in audio, and there was that transition between digital and analog, kind of in the late '90s, early 2000s, and there was a lot of people that swore against it. But now it's like, no one can tell the difference between analog and digital. Right. Really, the only thing that you can tell between the two of them is around the capture technique, and it's more around how good are you at making it sound real. And so I think there's some analogs that we can kind of look at as well.
Yeah. Thanks for that. We got pretty geeky there. Any other thoughts, concerns about reality? Any other insights?
Hi, it's Ren. Just to go back real quick to interoperability, I posted a link to Kronos.org. They're doing OpenXR, which they're trying to make a standard for all the bits and bobs to talk to each other. So if anybody's interested, check it out. And then the W3C also has a Metaverse interoperability group, but that's kind of dead at the moment. I'm waiting for the meetings to kick in, but that's something else the W3C actually has quite a few different like XR, VR, whatever groups, So you can check those out too. The community groups are open to anyone. You don't have to be a member of the W3C. As long as it's a community group, you just have to create an account. So
you also just reminded me, so tomorrow, so I'm the co-chair on the Xrsi privacy and safety framework. It is much more like information security focused, but if anybody's interested in joining the Xrsi group to help create these privacy standards, the launch of the kickoff of the 2.0 working group is tomorrow. I'll put a link and then I'll put it in Discord as well.
what time tomorrow? Because I have an XR Access CET meeting.
It's like,
Tuesdays are my busy days.
let me check. I should know off the top of my head, but I don't. So if
Thank you.
Yeah, no problem. It's like, I think it's like right around the middle of the day.
Oh, then I might be available.
It's happening tomorrow at 10, from 10:30 to 11:30.
Ooh, let me see. I think I'll be done with my meeting.
And here you go. I'll send it so everybody's got it.
Thank you.
And it's interesting. We maxed out. We had about 200 people that wanted to attend last year. We maxed out at 100. I think we got inputs from several hundred people throughout the year, whether they were legislators or researchers or engineers. So it's a very, very diverse, very, very smart group of folks trying to make sure that we are protected as these immersive systems are built out and standardized.
That's a massive group. I don't think any of the groups I'm in are even. No, I think there might be one where I have like 100 plus. I'm in immersive web and then immersive captions. And then the inclusive immersive web one, which is kind of a liaison. And been trying to get into some other ones, but just hasn't panned out with my schedule. But I'll definitely see if I can show up for this one.
Yeah, it'd be great. It'd be great to see you there. All right, so I will say that the next meetup will be on, I love this. It's a group called, I believe it's Act One. They're a local Arizona-based group that gets kids out on field trips to see art. And so they adjusted during the pandemic and actually implemented a entirely VR setup where the field trip would come to the classrooms, and they actually have like a whole loadout of like headsets and curricula. And so we will have folks from Act One talking to us about those virtual field trips and how they've been able to successfully implement VR technology for schools so that kids can actually get to art.
Cool. Thanks, Fox.
Yeah, thank you, Austin. All right, folks. This has been another episode of Phoenix VR for Good. We'll keep it rolling. If you guys think of anything, we're all ears. Always up for having you all present as well, or anybody that you think is super cool. Thanks for coming.
Take care.
Thanks for
Bye.
hosting.